Tonight, you are going to perform a magic trick, and you won't even realize you're doing it. You will lie down in the dark, pull the blanket up to your shoulders, and close your eyes. You will remember the texture of the sheets, the ambient hum of the room, and the chaotic loop of thoughts running through your head. Then, you will wake up tomorrow morning, and there will be a blank space, a missing block of time. If someone asked you to pinpoint the exact second you crossed the line from being awake to being asleep, you couldn't do it. You can remember the before and you can remember the after, but the middle is a complete ghost. We spend a third of our lives in this alternate state of consciousness, yet the doorway into it is completely wiped from our minds every single night. This is not an accident, and it is not a lapse in attention. It is a precise, hyper-engineered biological blackout. The moment you fall asleep, your brain performs a targeted strike on your own memory, erasing the final few minutes of your waking life. And the reason it does this tells us something profound about how the human mind constructs reality. To understand why this happens, we have to look at what the brain is actually doing in those final, fragile moments of consciousness. For decades, scientists assumed that falling asleep was like turning off a computer. You flip the switch, the power drains, and everything goes dark at once. But modern neuroimaging has revealed that sleep onset is not a single event. It is a slow, uncoordinated retreat. Different regions of your brain go to sleep at different times in highly orchestrated sequence that takes several minutes to complete. The first thing that changes is your brain waves.
When you are awake and alert, your brain is firing high-frequency beta waves. As you lie down and close your eyes, these slow down into alpha waves, the signature of relaxed wakefulness. This is the twilight zone, a state known as hypnagogia. Your thoughts begin to lose their logic. They drift, fracturing into bizarre images, half-formed sentences, and sudden, vivid daydreams. You are still awake, but your grip on the external world is slipping. At the center of this process is a small egg-shaped structure deep within the brain called the thalamus. Think of the thalamus as the ultimate sensory gatekeeper. Throughout the day, every piece of information from the outside world, the light hitting your eyes, the sound of traffic, the feeling of your clothes against your skin, must pass through the thalamus before it can reach the cerebral cortex, the outer layer of the brain where conscious awareness happens. The thalamus decides what gets through and what gets ignored. But as alpha waves give way to the slower theta waves of stage 1 sleep, the thalamus begins to change its behavior. It starts to fire in bursts, effectively closing its gates. It cuts off the supply lines of the outside world. The sounds around you fade, the physical sensations of your body dissolve, and the cortex is left isolated, running on its own internal loops. This is the physical transition into sleep, but it still doesn't explain the missing memory. Because even while the thalamus is closing its gates, the cortex is often still generating thoughts and dreams that feel entirely real. You are still experiencing things, so why don't you remember them? The answer lies in a phenomenon called sleep-onset amnesia, and its discovery came from a series of elegant, disruptive sleep lab experiments.
In the mid-20th century, researchers wanted to find out exactly when memory drops off. They placed volunteers in sleep labs, hooked them up to electroencephalogram machines to monitor their brain waves, and waited. The moment the machines showed the first unmistakable signs of sleep, the appearance of sleep spindles and K-complexes on the monitor, the researchers would abruptly wake the subjects up. If they woke them up just 30 seconds after they fell asleep, the results were fascinating. The subjects could vividly describe what they were thinking about right before the alarm went off. They would describe strange, dreamlike sequences or fleeting thoughts. But if the researchers waited just 10 minutes into sleep before waking them up, something strange happened. The subjects could no longer remember those final few minutes of wakefulness. The memory of being awake, of thinking, of listening to the lab equipment had been completely erased. It was as if the brain had allowed them to experience the transition, but had refused to save the file. To see how this file gets lost, we have to look at the brain's recording apparatus. Memory is a multi-step process. When you experience something, that information is temporarily held in a structure called the hippocampus. The hippocampus is the brain's clerk, constantly scribbling down notes about what is happening to you in real time. Later, usually during deep sleep, the hippocampus transfers those notes to the neocortex, where they are filed away into long-term storage. But here is the critical flaw in the system. The clerk goes home early. During the transition to sleep, the hippocampus is one of the very first brain structures to shut down. Long before the rest of your cortex stops processing information, the hippocampus turns off its recording equipment. It stops encoding new experiences into short-term memory. This means that during the final 2 to 5 minutes of wakefulness, your brain is still perceiving the world, still generating thoughts, and still experiencing the drift into sleep, but the system responsible for saving those experiences is already offline. It is a brief, localized retrograde amnesia. You can't remember falling asleep because, logistically, your brain had already stopped making memories before you actually crossed the finish line. This leaves us with a deeper, more unsettling question. Why would evolution design a brain that cuts its own feed early? In nature, every biological mechanism carries a cost and a benefit. Why waste energy maintaining a brain structure that intentionally blinds us to our own transitions? One compelling theory among neuroscientists has to do with memory contamination. The human brain is a prediction machine, constantly trying to separate reality from fiction to keep us alive. When you enter the hypnagogic state, your thoughts become highly hallucinatory. You might hear your name being called, see flashes of geometric shapes, or feel like you are falling. If the hippocampus remained fully active during this transition, it would record these hallucinations with the same vivid authority as it records real-world events. You would wake up the next morning with your memory database corrupted, unable to distinguish between a real conversation you had at dinner and a half-dreamed conversation you had while drifting off. By shutting down the recording system early, the brain draws a hard, clean line between objective reality and the chaotic fiction of the dream world. It protects the integrity of your waking memories by ensuring the border crossing is never logged. But there is another, perhaps more existential reason for this selective blackout. The transition from full consciousness to complete unconsciousness is arguably the most radical shift the human mind undergoes. To go from active, self-aware agency to a state of total vulnerability and lack of control is a terrifying prospect for a survival-oriented brain. If we were forced to consciously experience the slow, agonizing dismantling of our own ego every night, watching our thoughts lose logic, feeling our sense of self dissolve into nothingness, it would likely trigger a profound panic response. The threat assessment system would flare up, shot through with adrenaline, pulling us back to full alertness. We see this happen occasionally in people who suffer from sleep paralysis or severe insomnia, where the boundaries blur and the mind panics at its own loss of control. Sleep-onset amnesia acts as a psychological buffer. It is a built-in mercy mechanism. It ensures that the surrender of consciousness happens behind a curtain, keeping the conscious mind blissfully unaware of its own temporary extinction. The next time you lie in bed, waiting for sleep to take you, try to notice the exact moment your thoughts begin to fray. Notice the point where logic bends and the images become strange. You will find that no matter how hard you try to stay alert, you will never catch the transition. The brain will always win. It will quietly dismiss the clerk, close the gates of the thalamus, and gently erase your footsteps as you step across the border. You will go quietly into the dark, and your waking self will never know exactly when you left.